we are going to, as promised, look at the financial mathematics question. Now, what I like about this question, it was given to us by Meli Matsuiki. Meli, welcome to the show. I hope you're watching. What this question is doing is it's deferring an investment or deferring a loan. Now, by that we mean that you don't start paying immediately. It's those advertisements that usually come out at November at the end of the year. Car sale advertisements where they say, buy your child a car that's going to college or university or whatever and only start paying in March the next year. That's a deferred annuity. Okay, so let's just get our language right. An annuity is something that recurs at the same period. We're making the same payments. Then it's an annuity. If the periods are the same but the payments are not, then it's not an annuity in the sense that we work with them at school. Okay, so an annuity, regular payments, regular intervals, and this is what this is about. It says, on the 1st of June, a bank granted Tabiso a loan of 250,000. So I think while we're busy with this, our present value of our loan is 250,000 Rand at an interest rate of 15% per annum compounded monthly. We need to pay attention here. Remember, this is what we call a nominal monthly rate, because your stated period, which is per annum, does not correlate with your compounding period, folks. In financial maths, you cannot use this interest rate. You need to change it to an effective rate per period. And in this case, we're going to change it to a per month rate. So let's do that while it's on the screen. We're going to change it to a decimal by dividing the whole thing by 100 and then also dividing it by 12 to make the per year per month. Remember, there's 12 months in a year. So you're going to take this 15 and you're going to divide it by 1200. And if you do that, you get 0.0125. Okay, and that's our effective rate that we have to work with. We've got to work with that value of I. Okay, so we've taken care of that. It says she wants to buy a car, clearly. So Tabiso agreed to repay this loan in monthly installments commencing from the 1st of July 2016 and ending 4 years later on the 1st of June in 2020. Now, folks, remember, you absolutely make, if you pay loans back, your first payment is made at the end of the first period. If you make an immediate payment, it's taken like a deposit, comes off the purchase price of whatever it is that you're going to buy. Okay, Tabiso is unable, to make the first 2 installments and only commenced with the monthly installments on the 1st of September 2016. Okay, I think we need a timeline. Always, always, folks, put your information on a timeline so that you can see how you play on that timeline. Timeline 1, nothing happened. Timeline 2, nothing happened. She started paying at this point, the regular payments, and then it continued for the 4-year period. 4 years have 48 months. Okay, and the present value was over here. So there's a period of 2 months that Tabiso could not pay. Okay, and we call that a deferred annuity. Okay, so this is where the deferment took place, is the first 2 months. For this, we have a formula. For that, we have from here to there, we have the present value formula that works for us. Remember, for the present value formula, there's got to be that one period open at the beginning of the loan. So even though she only started paying at T3, there was a deferment up to T2. We take the deferment for the first 2 months. Now, what does the bank do? They add interest for those 2 months. Okay, let's see what the first question says. Calculate the amount that Tabiso owed the bank on the 1st of August, a month before the first payment was made. So what they're asking you is a future value. They're asking you what is the future value here at T2. Okay, so for 7.1, or yeah, it is a question 7. For 7.1, we're wanting the future value at timeline 2. Now that is the present value with this as a normal compound interest sum, folks. There was nothing happened in those 2 periods. No payments, nothing. So it goes forward at compound interest for 2 months. And the interest is 1 plus I. So 1,0125 for 2 periods. And all we now need to do is plug this into our calculator. 250,000, 1,0125, all to the power of 2. And if we put that into our calculator, we get 256,289,06. So just look at this. There's what is this amount? 16,300 Rand. No, 6,300 Rand, more or less 6.3 in interest that was added for those 2 payments that did not happen. Okay, now the annuity is ready to run. Question 2, that was for 2 marks. Question 2, having paid the first monthly installment on timeline 3, the 1st of September, Tabiso will pay his last monthly installment on the 1st of June. Calculate this monthly installment. So it's just the annuity is now running as per normal. Now, folks, you've got to realize the moment you interrupt an annuity, it's like one of those shongololos, those things with 1,000 legs. If you touch it, it shrivels up. That's what an annuity does. If you interrupt its rhythm, the annuity shrinks up, shrivels, and gone is the annuity. You have to reformulate a new annuity. Okay, so even though he signed for the car at timeline 0, he did not know that he's going to run into trouble and couldn't make the first 2 payments. Okay, so the annuity now looks different than what it did on the original agreement. He's got to pay more to complete this loan in the said period. So let's structure that. 7.3. Our new value of our loan will be 256,289,06. That is the new payment that we're going to call X in this case. Now, folks, remember this. This is big. If I put the annuity formula down here, present value is X, 1 minus 1 plus I to the minus N over I. That value of N is not, listen carefully, it is not the period of the loan. It is the amount of payments inside the annuity. If there was no problem here, if Tabiso started paying at T1, then that N will coincide with the period of 48 months. Okay, so what I'm trying to say to you is that N is not 48. In general, the N in the annuity formula represents the number of payments inside the annuity, and that's the catch here. Okay, so if we structure our annuity, we get 1 minus 1,0125 is 1 plus I, and to find this N value over here, we say it's the top minus the bottom plus 1, like we would have done in a sequence. 48 minus 3 is 45, plus 1 is 46. Okay, so instead of being 48, there's 46 payments in this annuity. Make a note of that, folks. The N in the annuity formula is not the period of the loan. It is the number of payments inside the annuity. Okay, so now it's time to get your calculator out, throw all of this information in there, and if you did not make a silly mistake, your calculator will tell you that X is 7359,79. Now, folks, I don't want to sit here and punch into a calculator and have you watch me punch it in. Just write that answer down. Maybe take a photo with your cell phone, write that answer down, and go and take out your calculator and calculate how I got to this. What I usually do is I find this sum first, I turn it around, and I multiply with this number on the other side, and that gives me the value for X. Okay, the third part. If Tabiso paid, now look, listen to this. Tabiso couldn't afford the first two payments, but suddenly, good, his financial situation improved, and he can now pay 9,000 Rand a month for the full period of this loan. Okay? And starting at the same time. How many months sooner will he repay the loan? Now, this is beautiful. This is why I like this question. It throws everything on its head. It now says he's going to pay 9,000 a month. Our formula stays the same. There's the formula that we've already structured. There's only two things that are changing now. Instead of having N, we don't have N. We must find N. Okay? We have X. X is 9,000. And we want to know how many of those payments must be made to complete the loan. So let's have a look. 7.4. Still the same amount of money. And our X is now 9,000 a month. 1 minus 1,0125 to the minus N. We want, that's the question. We need to know how many of those payments is Tabiso going to make to know by how many months did it shorten the loan. Okay, so divided by 0.0125. So let's have a look. We now have to get this term by itself. That's the term, possibly with the negative going along by itself. How am I going to do that? I'm going to take the right-hand side, I'm going to divide it by 9,000, times it by 0.0125 and subtract 1. Let's have a look. That divides into this. Okay, so then I multiply that across, and then I throw the minus 1 over. That brings me to minus 1,0125 to the minus N. That is equal to minus 0.64404. Remember, you never round off. 29722. You keep all those decimals on your calculator screen, because if you just go and you round it off to 2 or 3 decimals, your period is going to change significantly. Okay, let's go beyond this step. We can see that the negatives are going to cancel out, so they're going to become positive. So what do I do? Well, if this is the theory that you need to know to continue, if a to the x is equal to b, and I want to find x, we all agree that a and b will never be the same. It's two different letters in the alphabet. So to get to the x, we need to bring in logs. Okay? So the power x is equal to the log of b divided by the log of a. Or you could have said it's log base a of b for those of you that have a calculator with the base on it. Okay, so all that's left now for us is to take that log. So minus n is the log of this side, the log of 0.644, and remember, you put all those numbers in, divided by the log of 1,0125. Now, folks, if you do that on your calculator, you will find a number of minus 35,4187 and a few more decimals. Now let's talk about that. First of all, there's a negative on the one, negative on the other, they're going to cancel. So n is in actual fact 35, something. If that was 35,1, folks, you don't round this answer off at all. If that was 35,1, there's 36 payments left. Please don't be tempted to say 35.4. If I round it up or round it down, it is 35 payments. It's not. What does this answer mean? Let's see. This tells you that there will be 35 payments of 9,000 Rand each and a 36th payment which is less than that 9,000. So in total then, the amount of time that was saved on this loan is the initial period of the loan. So let's write that down. Saved was the initial period of 48 months or payments returned to 36 payments, which in this case are done monthly. Okay, so it's right to think of it as months. So there was 12 months shorter, a whole full year. Instead of paying the 7,300, pay 9,000 a month, and you save a year of interest and you save a year on this loan, the period of the loan. Okay, we're not done yet. The last part says now the last part is asking us, what is that final bit at the end? Okay, now let's have a look. If we go to our initial timeline, we know the following. We now know that this and that, there, you've got to be very wide awake in this question, is 9K. This is what he paid. Okay? The loan started running at this point over here. Okay, that's where the loan started running. We could start with a loan at 250,000 if we want to, okay? But we're going to start with it at T2 because we have the amount that was borrowed at T2. So what do we need? We need this present value, which we do have. We need the present value of all those payments. Now remember, there was 46 of those payments initially at the initial rate. But now if he pays 9,000, which is what the question says, he pays 9,000, how much is the final payment? This 36 or 46 is now 12 less in terms of the number of payments. Okay, so that will give us 34 payments made in the annuity of 9,000 Rand each. And then we go one further. So our final payment, the Y value, I'm going to call it Y, 7.4. Our final payment is the present value of this loan, which is 256,289,06 minus the present value of all those 9,000 Rand payments. Okay, so it is 9,000. We take it back, 1 minus 1,0125. How many of those payments? Well, we said there's 35 of them. So we take all the interest away, 0,0125, and this whole difference must go forward. Now I'm going to write this here. Go forward at 1,0125 for 36 periods. What does that mean? It means that everything came back to the point on the timeline where we started paying. Okay, we made 35 payments at 9,000 Rand each, and then the last payment is that little bit of a gap that we need to pay extra to amortize this loan. Okay, so we take everything, and this is what you need to understand about a timeline. If you work with timelines, folks, you've got to converge at the same point on the timeline. All the information has to go to the same point. So in this case, we went everything to T2. We had the present value, we brought the 9,000s back to that point, and then we said, cool, that's the difference that's left, 35 of those 9,000. So we move it forward, 36. So your final payment, you'll find out if you do all of this in a calculator. Remember, this is multiplied by that factor. Gives you 2418,34. That is the final payment that is made in Thabiso's loan to pay off the vehicle that he purchased. If he paid it at 9,000 Rand per month for the period that they said he paid. Okay, Merle, I hope that that explanation was sufficient for you and that you learned a lot from that. We worked with a deferred annuity, and by the way, I'm just going to tell you what they call these things. That last bit where we had a little bit at the end that we had to go and find out is called a fixed payment annuity. The payment is fixed, the period is not. We had to find the period. The period became a decimal, so we knew there's a little bit at the end that must still be paid to amortize this loan fully.